Okay, so let's just take a look at a handful of these questions. So 6 machines, each working at the same constant rate together, can complete a job in 12 days. Okay, so what we know is like we've got the rate for 6 machines, and it's 1 job per 12 days. We want additional machines each working at the same constant rate to complete the job in 8 days. So what that's telling you is one machine is doing the job in, just divided by 6, 72 days. So 1 job per 72 days, right? So then what we're going to do is, okay, so we want to complete the job in 8 days. So you've got 1 job, and that's going to be n times R1. That tells us how many machines we need. Jobs per day times 8 days, right? So what you've got there is 1 is equal to nr1, so it's n over 72 times 8. Drop these, so that's n over 9 is 1. So then 9 is equal to your n. So it's saying we had 6 machines previously, and that's telling us we need 9 machines to do the job. So how many extra machines? That's going to be 3 extra machines. So your answer should be B there. This one, 15. This is an interesting question because what we're looking at, so 10 to the 8 minus 10 squared, and then 10 to the 7 minus 10. If I look at this, I can tell you immediately what it should be roughly in terms of the power of 10, just because I'm looking at 10 to the 8 and 10 to the 7. These are massive numbers, and basically the 10 squared and the 10 cubed I can ignore. This is not a factoring question, it's an approximation question. So it's just being able to see what you can ignore. I can literally just go, all right, so 10 to the 8 minus 10 squared, and then I've got this 10 to the 8 over 10 to the 7 is just on the order of 10 to the 1. So your answer is this. You can think about this more like, look, you've got 10 to the 8, you've got 100 million, and you've got 100. So if you had $100 million, you would be lighting your cigars with $100 bills. It's irrelevant. And similarly, it's 10 to the 7 is 10 million. 10 cubes is 1,000. I mean, that's the tip of the ballet. So you don't have to worry about these numbers. And the thing is, if you plug this into a calculator, you're going to see that you're probably correct. It's going to be 10 with 10 something or other within about 3 decimal places. That should be correct, basically. And we can see that just because of that power of 3 there. Okay, a basket contains 5 apples, of which 1 is spoiled and the rest are good. Henry selects 2 apples simultaneously and at random. This doesn't really make any difference. That's just, they're putting that in for mathematical completeness. What is the possibility that the 2 apples selected will include the spoiled apple? Okay, so we've got 1 spoiled apple. So what we've got is we've got 2 possibilities. So it's the probability of spoiled and not spoiled, or the probability of spoiled, not spoiled, and spoiled, okay? Depending on which one he selects first, as it were. I know it says simultaneously, but you can think about it more like if you grab them both at the same time, which is the spoiled one on the right or is it on the left? Because it could be on the right or it could be on the left. So you've got to consider both of these things. So basically what you've got is, okay, the spoiled 1 out of 5 times not spoiled, which is 4 out of 4, if you make that selection first. Or the not spoiled, which is 4 out of 5, and then spoiled, which is 1 out of 4. So either way, it's going to drop down to 1 over 5. So depending on which way he selects it, he's going to select it this way or that way. So basically you just add those 2 together. So the answer should just be 2 over 5. Or you've got 2 possibilities. You've got spoiled, not spoiled, and not spoiled, spoiled. So you just take the 1 over 5 and multiply by 2. Because this 1 over 5 in a probability question like this, these values should be similar. Okay, so 17. A library assesses fines for overdue books as follows. On the first day the book is overdue, the total fine is 10. So table. Okay, so you're just going to have to draw a table and figure out what's going on here. So day and fine. So day 1, fine, 10. Each additional day is either increased by 30 or doubled, whichever is lesser, okay? So that's, all right, in this case, double it, because that's lesser. So that becomes 2.2. The next day, 30 cents or doubled. So it's still lesser to double it. So 0.4. And then the next day, 30 cents or doubled. So it's actually less to add 30 cents in this case. So that becomes 0.7 on day 4. Okay. So your answer should be 70 cents. Okay. So here's a nice data sufficiency question. So I guess this is technically DI, not math, but so be it. It's still mathematical. So what we're going to do, all right, 25 cars sold total. Some had automatic transmission, so we'll call that automatic transmission, and that's anti-lock brakes. How many cars had automatic transmission but not anti-lock brakes? So we're looking for this group, right? So the question is, can we tell? So all the cars that had anti-lock brakes also had automatic transmission. Okay, so that's telling you that's 0. Well, that's still not enough to tell, because we would have basically X, Y, and Z here that we don't know. Now, 2 of the cars had neither automatic transmission nor anti-lock brakes. Okay, so that's basically making Z 2. But then we still have the X and the Y. We don't know what the distribution between X and Y is, so we're not actually going to be able to solve this. So that should be an E answer. No matter what you put in, it won't solve. Okay. Is X between 0 and 1? Well, this is pretty easy. So X is between 0.5 and 1.5. That's not going to work, because obviously there's numbers that are negative and numbers that are positive. So this is insufficient. 3/4, well, this is literally just saying 3/4 is equal to X plus 1. Or you get an actual value for X in that case, so that one for sure works. That's a B. If M, R, X, and Y are positive, is the ratio of M to R the ratio of X to Y equal to the ratio of X to Y? So this one, okay, so look. The question itself is asking, is M over R equal to X over Y? That's the question, right? Now this one, M over Y equal to X over R. Now that's a statement. We're getting MR equals X, Y. But that's not the same as that statement, and we can't get to here from here. So no, that's not going to be, that won't work alone, okay? So that first one is insufficient. The ratio of M plus X. Now this one looks weird, but I think this one actually would function, depending. We'll just have to try it and see. So M plus X over R plus Y is equal to X plus Y. Oh yeah, it does work for sure. I'll show you why in a second. But you can multiply it out and just see this. MY plus XY is equal to XR plus XY. Your XY goes away. MY equals XR. So MY over R is equal to X, and then pull the Y down here, so M over R equals X over Y, and you're good. Now, the reason I said initially that it will work is there's a little trick. So basically, if I take something I know to be 3/4, for example, and then I take something I know also to be 3/4, and I add independently like this. So that's 9/12 is 3/4, but you have to add top and bottom independently. My result here is also going to be equivalent to 3/4. So this equals this equals this, right? That's the trick I'm noticing. So what's happening is that you have this and this equal to each other, which means that if that's consistent, then that has to be equal as well. So basically all 3 of those would have to be equivalent to each other in order to make that work. So in fact, that means that M over R does have to equal X over Y if that statement is to be true, okay? And that's how I could see that at the beginning. Well, thanks for watching, and yeah, go ahead and check out the free stuff that's available at the Stan store in the link, and then I will see you in the next live stream.